Good morning everyone, so I'm Dana Moas and I am from Group 3. And so today we're going to discuss the strategies in teaching mathematics together with my group mates, Denise Gabonada and Joyce Gaka. So right now I'm going to discuss about the problem solving strategy by George Polya. Okay, so first, who is George Polya? Okay, so George Polya was a great champion in the field of teaching effective problem-solving skills. He was born in Hungary in 1887, received his PhD at the University of Budapest, and was a professor at Stanford University. He is known as the father of modern problem-solving, did extensive studies and wrote numerous mathematical papers and 3 books about problem solving. So Polya published the short book How to Solve It, and which gave a four-step method for solving mathematical problems. So yes, again, George Polya was regarded as the father of the modern emphasis in math education on problem solving, a leading research mathematician of his time. So Dr. Polya made seminal contribution to probability, combinatorial theory, and conflict analysis. His work on random walk and his famous enumeration theorem have been widely applied. So George Polya's 4 steps method for solving mathematical problems. His first step is understand the problems. So sometimes the problem lies in understanding the problem. If you are unclear as to what needs to be solved, then you are probably going to get the wrong results. In order to show an understanding of the problem, you of course need to read the problem carefully. Sounds simple enough, but some people jump the gun and try to start solving the problem before they have read the whole problem. Once the problem is read, you need to list all the components and data that are involved. This is where you will be assigning your variable. So yes, here in step 1, we should figure out what is being asked, what is known, and what is not known, and what type of answer is required. So next, step 2, devise a plan or translate. So devise a plan. When you devise a plan, you come up with a way to solve the problem. Setting up an equation, drawing a diagram, and then making a chart are always that you can go about solving your problem. So in here, come up with some strategies for solving the problem. Just like what I said a while ago, that drawing a diagram and making a chart are one of the solving strategies in solving our problems. Next, step 3, carry out of plan. So this next step, carry out of plan, is big. This is where you solve the equation. You came up with your device as a plan step. You came up to the use of strategies chosen in step 2 to solve the problem. If you encounter difficulties using the strategy, you may want to use resources such as a textbook to help if the strategy itself appears not to be working. Return to step 2 and select a different strategies. So step 4. Step 4 is look back, check and interpret. You may be familiar with the expression, don't look back. Basically, check to see if you use all the information and that the answer makes sense. If your answer does check out, make sure that you write your final answer with the correct labeling. So for example, find 45% of 125. So in step 1, Make sure that you read the question carefully several times. We are looking for a number that is 45% of 125. We will let x equals the value we are looking for. Step 2. A number that is 45% of 125 is x equals 0.45 times 125. Step 3. X equals 0.45 times 125 is equals 56.25. So you're going to times the 0.45 and 125. And the last step, the step 4 is 56.25. It is the 45% of 125. So again, the 45% of 125 is 56.25. So that is our final answer. Okay, so now I will let Joyce to continue the discussion strategies in teaching math.
And here are the strategies in teaching mathematics. First, concept attainment strategy. Second, concept formation strategy. Third, think, pair and share. Fourth, time testing. And fair work. When we say concept attainment strategy, it allows students to discover essential attributes of concept. It enhances students' skill in searching for patterns and making generalization. Like for example, if a teacher wanted to teach his students the attributes of mammals, he could use the concept attainment model. He may have a stack of cards, each card with a picture of an animal. He would not tell his students the concept and ask them to guess the common theme themselves. So here are the steps in concept attainment strategy. Thus, to select a concept and identify essential attributes. Second step, present an example and non-example of the concept. Third step, let your students or define the concept and its attributes. The last step is ask the students to generate an examples. How is it effective to use a concept of attainment strategy? Each students are able to identify the essential attributes of the concept, and especially the students are able to generate or create in their own examples. And the second strategy is concept formation strategy. We can use this strategy when the students make connection among essential elements of the concept. Like for example, the concept square is used to describe those things that have 4 equal sides and have 4 right angles. So here are the 5 steps in concept formation strategy. The first step is to present a particular questions or the problem. The second step, ask your students to generate data and relevant the problem. The third step, let your students group with similar attributes. In the fourth step, label each group with similar attributes. And the last step is let your students to explore relationship between their groups. They may group in various ways and the other group based on their attributes. And how is it effective to use concept formation strategy? Enhance higher order thinking. So is it too easy to assume that students who appear to move through tasks quickly have all the skills they need? Students are able to give example to demonstrate application in concept. Share a concept and ask students to generate their own examples. The third strategy is think, pair, and share. This is a cooperative discussion strategy. Get from the 3 stages of action in the students are doing these stages. So the teacher provokes students thinking with question or the observation. And the teacher will provide a worded problem involving an area. The situational example of think is when teacher will allow students individually to solve the problem first. Pair using designated partners, neighbors, pair up to talk about the answer came up. They can compare their mental or written notes and identify the answer they think are the best and how is it unique. A situational example of pair is after 5 minutes, the teacher will ask her students to find a partner and discuss after the solution. While the partners are discussing solutions, the teacher will roam around to see which partner will able to make the correctly answer. Share. The students talk in pairs for a moment, and the teacher will call on students to share their thinking with the rest of the class. Like for example, the teacher will randomly select a partner to share their solutions in class by explaining and solving in the blackboard. The fourth strategy is time testing. Teachers progress basic number concept, addition, subtraction, multiplication, or the division that review prior lesson or several classes essential, and having a proof or workable, and how it is useful over a long period of time, and how is it effectiveness. Example is when teachers can assess students' understanding by taking a brief test and grading it in the class. Can tell if pupils have mastered the basic skills when exam reveals they answering more questions correctly. Next strategy is fair work. Mathematics does not have to be learned via textbook, lessons, or testing approach. Students have variety of learning styles and require courses that help to improve all of them in order to achieve the greatest result. When we say fair work, is learners working together in pairs. One of the main motivations to encourage the students, and it is a natural way for students to talk and learn more. It gives them the chance to think and try out ideas. It can provide a comfortable way for students and work through how and new skills and concept and work well. And students are instructed to partner in order to complete a task set by the teacher. And this allows them to compare answers. Like for example, the learners are work as pair and answer a problem and to solve. In the classroom, teacher can evaluate the effectiveness of fair work on learners by using action, asking the learners how they feel about working and participating in pair, and evaluating this experience afterwards. And here are the guidelines of work pair. Move your pair and get right to work. Part of pair working is learning to listen each other. Make sure each person's ideas are heard and that pair answers each person's questions. If you are confused, ask your pair to explain. If both pair can answer the question and it is important question, raise your hand for the teacher. Give your pair a chance to talk about his or her ideas. Be prepared to share ideas, solutions, and strategies to explain why you think you are correct. Make sure you look back at the original problem and check your solutions make sense.
Hi guys, this is Teacher Dan, and I would be continuing about the strategies in teaching math. So we have here number 6, manipulation of tools. Students can learn and grasp basic abilities more easily with manipulation of tools. Like when children learns best through hands-on experience and construction rather than traditional teaching and repetition. These are great. The use of blocks, fruits, balls, or other manipulation tools help students learn the basic of place value, addition, subtraction, and other areas of the basic math. So, it is like we are using things, anything that's attractive to kids or anything that's attractive to children, we can use that as it's manipulation of tools. We can use that in addition, subtraction, counting numbers. So that's the use of manipulation tools. Here we have math games. So math games, teachers may find it difficult to reinforce knowledge gained in class, but math games provide an opportunity to make the lessons more engaging and motivate students to recall the principles. So, games might vary depending on the class size, computer availability, and the topic being taught. Teachers might utilize computer games to teach specific skills, or class games to make the session more enjoyable. So teachers should make sure that games include technique to aid students in learning the topic. We can use games we can use games. It is one of strategy in teaching math. We can use games because the students the students participate more, would also learn more knowledge. The example of teaching games, using games as the lesson or the topic, it is the Simon Says geometry. So when we say Simon Says, the students would be following all the commands. So appeal to kinesthetic learning by playing this version of Simon Says, and in the process improve their understanding of basic geometry. So as Simon Says, all your commands should require students to illustrate angles and shape by moving their arm. For example, ask them to make angles of varying degrees as well as parallel and perpendicular lines. Continuously up your commands and change if they come from Simon or not, until only one student remain, and it is the winner. So when we play Simon Says, we are we make commands. We make commands to students, and from that, students learn on what they're going to do. So we have here the next one would be number 8, the repetition. A simple strategy teachers can use to improve math skills in repetition. By repeating and reviewing previous formulas, lessons, and information, students are better able to comprehend concepts at a faster rate. Example of teaching math would be teaching number. A teacher and the students will be able to count the numbers from 1 to 100 until they will memorize the sequence. So like in our lower grades, we let children count 1 to 100 over and over again until they will learn, or they will know the sequence from 1 to 100. Next would be time testing. When teachers progress from basic numbers concepts through addition, subtraction, multiplication, and division, time tests that review the prior lesson or several classes are essential. So we need time in learning those addition, subtraction, multiplication, and also division. Teachers in time testing, teachers can assess students understand by taking a brief test and then grading it in class. So teachers can tell if pupils have mastered the basic skills when the exam reveals that they are answering more questions correctly within the time limit. So teachers gave evaluation to students with the time limit. So it is the time testing. Next would be use of visual and images. Another evidence-based strategy to help students learn abstract mathematics concepts and solve problems is the use of visual presentation. Yes, in elementary class, students would appreciate if we have those images or visuals that they can see what they are learning. They can learn more if they if they have the thing that they could visualize. So in visual and images, more than simply a picture or detailed illustration, a visual representation, often referred to as a schematic representation or schematic diagram, is an accurate depiction of a given problem's mathematical quantities and relationship. So the purpose of this visual is to reflect the student's understanding of the problem and to help her correctly solve it. Visual representations are flexible, so they can be used across grade levels and types of math problems. And they can also be used by teachers to teach mathematics facts and by students to learn mathematics content. So visual representation also can make a number of forms. Click on the link below to view some of the visual representation most commonly used by teachers and students. Okay, so here is an example of visual and images. In this photo to the right, a student is using a visual representation. Here, a pie chart to learn about equivalent fraction. Despite the fact that teachers implement this strategy in the early grades to help students learn basic math facts, students with mathematics learning disabilities and difficulties often do not continue its use on their own to solve problems. But visual and images is also one way in strategy in teaching math, since especially math that we are like more on numbers, so it is better to show some visual representation to maybe learn more or learn faster than the usual that we will just tell them what to do. Here is also one of an example. It is an elementary example. So Mrs. Ulrich asked her first grade students to add 2 plus 4 by drawing dots. Yeah, it is like the same of the manipulation of tools. We used items, we use fruits, anything. But this one, it's also a visual. We can use dots, we can use stars, we can use circles in teaching. So here, Talia draws the following, and that's it. So Talia did draw there 2 dots and also 2 dots and 4 dots. So that's 2 dots plus 4 dots would be 6, equals 6. So with the help of dots, it is more faster. We are more faster to learn, especially in math. So here is another example. Colby draws the following. So it's not really clear, but 2 dots plus 4 dots would be 2 plus 4 equals, that would be 6. Wait, I was confused. Yeah, 2 plus 4 equals 6. I'm sorry for the typo, but yeah, 2 plus 4 equals 6. So notice that Talia, okay, here. So yeah, that's why I'm confused, because it would be called the when Mrs. Aldrich asked her first grade if there are 2 students that are answering. So Talia got the correct answer, but Colby did not got the correct answer, since 2 plus 4 equals 5. So that was the Colby's answer. And we know that 2 plus 4 is equal 6. So notice that Talia gets the correct answer. However, because the Colby draws his dots in haphazard fashion, so it's not really clear as what Talia draws, but still to count all of them consequently, arrives the wrong solution. So if the wrong visual, it would also make our student got the wrong answer. So I guess that's the last part. So thanks for watching.